lives in sin and misery in the house of the rising sun.
Hello, everybody, and welcome to South Africa. I hope you enjoyed that little tour of our oceans. My name is Nicole Mostert, and I'm with EDU Africa. Today, we have an absolute privilege to participate in this marine biology session with practical engagement in great white shark identification and monitoring. A special welcome to the students from the University of Northern Iowa who are joining us today in the promotion of their Ocean Conservation Virtual Exchange Program. So although this is a small piece of the 5-day program, we hope this gives you a better understanding of what virtual engagement looks like and that you'll be eager to participate in a full program. A very warm welcome to faculty and students joining this demo from other colleges and universities, both in America and the UK. We're thrilled to have 3 continents collaborating online today. So it's such a good reflection of just the world of virtual exchange and how it can bring us closer together as we engage and learn from one another. So please note this session has been designed as a demonstration. So it would typically form a part of a more extensive virtual exchange program that includes a variety of virtual engagements, but I'm sure you will like this small taste today as well. As I said, my name is Nicole Mostert. I'm a program manager at EDU Africa, based out of Cape Town, South Africa. And my colleague, Ashley Cilliers, is joining me as well as our technical support today. All right, so today's session, our goal is for you to really understand how marine biology and ocean conservation studies can be done in an interactive way on a virtual platform. We'll be doing this by learning about the process of great white shark monitoring in a presentation by Marine Dynamics, practically applying what we've learned about shark fin identification in a breakout room activity, and then sharing our findings in the main room after that. I'd like to know who's here, as this is an engaging session. So if you could just write your name in the chat, which institution you're from, and then also a more exciting question, if you could be any ocean creature, which ocean creature would you choose to be? I'll just wait. Now I have to think. I think the whale always catches my heart. They're just so huge and they jump so high, and I always wonder how they can do that. So I think that would be my answer, but I'd love to hear your answers as well, and just find out a little bit of who is here with us today. All right, we have Nicholas from Algeny College. Wonderful. Marissa from the University of Northern Iowa. She'd like to be a dolphin. Amanda from West Virginia University, watching with her son, Andrew. Hi, Andrew. You chose to be a megalodon, and my stepson would have chosen the same thing as you. Jenny with Fellowship Travel, the narwhal whale, wonderful. We have Roy Smith from Nottingham Trent University, a cuttlefish. Peter from University of Northern Iowa, Coelacanth. Wow, I just showed that I don't know my marine biology by mispronouncing that name. Maybe our contributor can help us later. Paula Van Zee from the University of Northern Iowa, dolphin. Brandon, Augusta University, marine iguana. Wow, what a diversity we have here. Suzanne says whale. Catherine, Nottingham Trent says humpback. Carolyn McReynolds, University of Northern Iowa says seal. You all have to come to South Africa. These are all the animals we have right outside our front door. Jennifer Sink of Davidson County says shark. Brian Rank from Arkansas Tech University says orca. Charity says from the University of Northern Iowa says sea cucumber. Oh, I like that answer. I'm not sure if we have that here. Hannah from Nottingham Trent University says a white shark, of course. Oh, you're going to like today's session, Hannah. And Peter Ruffle from Nottingham Trent says either a whale or a turtle. I know sometimes it's hard to choose, but I would go with both of those. Ali from UNI says dolphin, and Brittany from Allegheny College says dolphin, and Isabella from Allegheny College says shark. I think that's a good start. I like the variety, and I'd have trouble choosing, that's for sure. All right. So what I'd like to do is, before we get started, just go over a few house rules. This session is recorded. If you could turn your video on, if at all possible, that's wonderful. It just makes us feel more connected across the continents. Please keep your mic on mute while our contributors are sharing. When you're in the breakout room, feel free to unmute. That would be great. Please use the chat function to share your thoughts and pose any questions. So all the way through, it'd be great just to hear your comments and your questions. We'll get to as many, answering as many questions as possible. Please note that you'll be hearing facilitators and participants from different cultures, different accents. So if you do have any trouble understanding us, then please just ask us to repeat in the chat. And apologies in advance if we have any internet connectivity issues or slow video. Be patient, and we've got plan B's, C's, and D's. So we've got backup plans for that for sure. All right. So at EDU Africa, we facilitate transformational learning journeys in Africa. We believe in the power of connecting disciplines, histories, stories, and skills as a powerful movement for student transformation and positive global change. So whilst physical travel is restricted, we have really seen the power of virtual exchange programming. It's not new, but it's definitely been highlighted in our current global climate, as I think everyone would agree with. Our VE programs are fully customizable, critically engage students with different stakeholders, project work, activities, and experiences. We draw on many of the traditional COIL principles, but we're a partner and not an academic institution. Our VE programs are defined by not defined by student-to-student collaboration and engagement, but rather by student collaboration with industry leaders, communities, NGOs, and other heroes and bodies in Africa. We understand that for virtual exchange to be optimally successful, it requires sustained engagement, facilitated discussion, and collaborative project work between individuals and entities. So we hope our session today will inspire you to create your own virtual learning opportunities. There's so many exciting opportunities out there, and it's exciting to see this one today. So to help us get a taste of what's possible with virtual marine biology and ocean conservation programming in Africa, we have the amazing privilege of welcoming Kelly Baker today. Kelly is a marine biologist and a guide with marine dynamics in Gansbaai, South Africa. She has a particular interest in great white sharks and is here to share a little of that passion with us today. So without any further ado, please welcome Kelly Baker.
Okay, good afternoon from South Africa, everyone. So like Nicole said, I'm part of the biology team with Marine Dynamics and the Daya Island Conservation Trust. Originally from Australia, I joined the team back in 2014. And my interests lie in population dynamics of the great white sharks, But as of more recent, the oviparous chondrithians that we find in this area. In the time that we have today, I'm really hopeful that you will leave with a better idea of the work we conduct, more specifically, a clearer understanding of one of the main elements to the research that is undertaken in regards to the great white sharks that visit this area. But before that, just briefly, who are we and where are we? So we are a group of organizations that work together towards the same mission, and that is broadly to discover, protect, and educate. We have the commercial operations of marine dynamic shark cage diving and Daya Island Cruises, that's the whale and eco tours, the Marine Dynamics Academy, and that covers our volunteers and interns on a local, national, and international level, and of course the conservation and research aspects under the Daya Island Conservation Trust and African Penguin and Seabird Sanctuary. We're based in Gansbaai, South Africa. Now in Afrikaans, Gansbaai translates to Goose Bay due to the Egyptian geese that are found in the area. And we're located approximately 2.5 hours southeast from Cape Town. We're very close to the most southern tip of the African continent, Cape Agulhas, and that is also the official division between the Indian and Atlantic Ocean, or oceans, sorry. The marine area we work in is a critically important ecosystem and home to the Marine Big Five, which of course does include the great white shark. The zone in which we are permitted to operate is approximately 118 kilometers squared. Perhaps correct me if I'm wrong, but I believe that's about 40 to 50 miles squared. However, certain research projects, such as our telemetry program, do have an extended zone. The bay, simply put, is pretty much made up of large areas of sandy beds, rocky reefs, and a pretty extensive amount of kelp forest. Now, over the years, the area has become known for one of the most abundant populations of white sharks globally, or a hotspot. Whilst this species is widely distributed and known to undertake extensive migrations, they also exhibit semi-annual site fidelity to coastal locations, which is often associated with pinniped colonies. In the case of Gansbaai, that would be our 60,000 strong Cape Fur seal colony. So essentially, this is pulling individuals to known accessible locations. Now, in regards to conservation of the white sharks and their status, with sharks gaining recognition as a global conservation priority, a wider range of methods for accessing population levels has been deemed critical for effective approaches for the management and conservation of populations. Following concern over apparent white shark decline, they were given full protective status or protection in South African waters in 1991, and subsequently in Namibia, USA, Australia, and so on. They have also been listed in Appendix 2 of CITES and are currently assessed as globally vulnerable on the IUCN Red List. So locations like Gansbaai, they can or have provided a unique opportunity to study the South African population of great white sharks. Now, there are a number of characteristics that define a population, but today, however, we are going to be looking at population size, which is the number of individual organisms in a population. And we're really going to be looking at how you could go about measuring that. Now, we could do a complete count. However, this is only really going to be helpful if perhaps you have a small or immobile population. If that is not the case, we could look towards sampling methods such as capture mark recapture. Could I have the next slide, please? So the method of, or this method of capture mark recapture, commonly used to estimate a population size where it is impractical to count every individual. So simply speaking, a portion of the population is captured, it's marked and released. perhaps that individual recognition may be achieved by applying an artificial mark or a tag to the animal. So I've just included a very simple diagram there. Let's say you would wish to look at the population of a specific fish species in a pond. Your first sample would be marked, released back into that population, and at a later date you would recapture, and that portion of the originally captured or marked animals is thought to or assumed to represent the marked portion in the entire population. But during our breakout rooms, we will look into that a little bit more. Now, in regards to this, though, the marking or perhaps tagging can be logistically difficult for species that are, say, hard to capture and or recapture. So this is where other methods may come into play. So photo identification has become a widely accepted method of mark recapture that has been tested over a broad range of species. So this method offers a non-invasive alternative for populations in which a reasonable proportion of individuals can be recognized on a recurring basis. And this is as a result of natural markings or features. You can see a number of examples on the screen now. Unlike artificial marking or tagging, photo identification allows the capture and recapture, or in this case, we could say the sighting and resighting of individuals without inducing capture stress. Furthermore, photo identification is relatively cost effective, and it can also allow for the participation of citizen scientists in the data collection process. In regards to our ongoing data collection for monitoring of the great white sharks, it is the dorsal fin that is used as the unique feature to distinguish individuals. This is commonly referred to as fin identification or fin printing. This technique was commonly used for cetacean studies. However, in the 90s, it was successfully transferred to a number of shark species. So a great white shark is born with a unique trailing edge to its dorsal fin. It's characterized by distinctive shapes, notches, scarring, and pigmentation patterns, and it can be used to recognize individuals over many years. Now, during its life, this edge can undergo changes, both insignificant and significant, and this is caused by such things as inter or intraspecies interactions and anthropogenic influences. However, with consistent and long-term sampling, these changes can actually be tracked. So I have just a few examples to show you how these changes in the edge can occur. My first example here is pretty insignificant. You can see between 2007 to 2011, there's not too much of a change in that dorsal fin. The changes really are just along the trailing edge in regards to some additions of small notching. The second example focuses more so on the pigmentation pattern and the change that can be seen there. With the pigmentation you're seeing here, we just commonly refer to this as rosy. It is found on the dorsal fin and caudal fin of certain white sharks. So like the trailing edge of the dorsal fin, this pigmentation can change over time. However, unlike the trailing edge of the dorsal fin, it's not found on every individual. Now, in regards to the change in pigmentation, this could be the size, it could be the shape, and it can also be the actual intensity of that pigmentation. So again, between 2007 and 2011, we actually saw quite a significant change in the pigmentation on this individual's dorsal fin. The third example I'm just going to quickly show is more significant changes to a dorsal fin across that time period. Chances are this is unfortunately interaction with humans. You can see between 2007 and 2011, the leading edge and the trailing edge has actually changed quite a bit. However, again, with the consistent sampling, it is possible to track these changes over that short period between the first and second image, and furthermore into the future. Now, you have a little bit of an idea about what we're focusing on in regards to fin identification, but what is it that we can use these for? So I'm just going to work you through one of our previous studies for the area, and that is the great white shark population estimate based on the images captured in this region. Now, that study was conducted between December 2007 and January 2011. During that time, photo identification images were collected during commercial shark cage diving trips. So we use this paid-for platform to collect as much information as possible. And at this current time, we have one of the most extensive white shark fin identification databases in the world. The effort that was put in here in regards to the collection of the fin identification photos spanned across 1,647 trips for 4,120 hours. And in that time, 20,000 fin ID images were collected. So we're looking at a large data set there. So where do we go from here? This is where we need a little bit of quality control. So the images are assigned a quality rating. This still continues to this day. This is done as defined by Goins and Whitehead. A ranking of 6 is considered to be a fin ID of the highest quality. So that is to say that the fin is clear of the water, it's square onto the camera, it's got good focus, lighting, and it's got adequate zoom. The Q ranking, it does decrease as the quality of photo ID decreases. It was found during this study that only images of Q4 and higher provided sufficient information to recognize individuals and allow for recapture or resighting of the individual. In the end, that was a total of 1,683 images from the original 20,000 that met the requirements for quality control. Now, there can be a few problems with this technique. So even though it does have its advantages, there is the potential for large databases like we're discussing now to compromise the reliability of matches made by eye, which can subsequently jeopardize reliable estimates. So this problem has been largely overcome, and that is with the use of computer-aided image matching software that match various unique features of individuals. The software that we have used for the study, and we continue to do so, is Darwin. And Darwin is capable, or it traces and assigns a fixed spacing of points along the leading and trailing edges. You can see an example in the lower image there of Darwin doing its work. So this trace then is compared to the entire catalog, and it is ranked by probability of a match. Saying that, in what I mentioned earlier about the changes over time to pigmentation and scarring and shape, the final match is actually confirmed by eye. Then, of course, with the analyses, the mark recapture analyses of the sightings histories of the recognizable individuals was performed using program MARC with the assumption of an open population parameterization was applied. Now, what did we find from this study? So the results to this is that this study revealed pretty much the longevity of individually recognizable features and the degree of individual sight fidelity are actually sufficient to allow for both long-term recognition of individuals and the estimation of the population using mark recapture models. It was found using the fin ID matching software Darwin. It identified 532 unique individuals Furthermore, the mark recapture model produced a population estimate of 908. Now, these findings, they were actually on par with previous estimations produced. That was 16 years prior to this study, unfortunately suggesting that the species had not so much made a marked recovery since nationwide protection here in South Africa in 1991. Future directions in regards to these methods and study include revisiting population estimates based on the years post-original study, utilization of more current image matching software. It has evolved since the original study. At this time, however, there is a study being undertaken. This is a collaborative effort, that is to say, in the sense that the data from known aggregation sites along the coastline has actually been volunteered and pooled with the hopes of a more extensive nationwide population estimate in the future. So that's just a bit of an intro and example to what we can do or what we are doing in regards to monitoring of individual white sharks and the population as a whole here in Gansbaai. I would actually like to have the breakout rooms with each of you being assigned a room. I have made a little bit of an activity. At the end of the day, with the time that we have, it's relatively basic in regards to estimations for population sizes. But what I would like everyone to do in their rooms, I have provided 2 samples of thin ID photographs. I would like the groups to look at those samples. The first sample is the first capture, and the second sample, of course, is at a later date. If the groups could give it a go at manually identifying recaptured individuals using those dorsal fins, that would be fantastic. And based on that, I've just done perhaps maybe not the most realistic scenario, but again, due to the time we have today, if the groups could assume this is a closed population and just do a quick calculation as to your population estimate for these samples. I believe in the chat, we should have the examples or the samples, the images, and just a quick outline of the activity itself.
Wonderful. Thank you, Ashley. Could you send us to our breakout rooms?